I have recently I have finished my PhD from Delhi Technological University, India, and my work is on landslide susceptibility and landslide hazard mapping in Indian continent in Himalayas. Uh, Currently, I am working as lecturer in Department of Technical Education, Government of Uttar Pradesh, India. So good evening, ladies and gentlemen. Our work is on landslide hazard assessment using analytic hierarchy process. And we have implemented this on along National Highway 5 for a particular stretch that lies from 197.600 kilometer to 283.200 kilometer. Uh, this is my PhD work and it is a part of my PhD work. However, we have implemented other techniques for landslide hazard assessment in India too. But this paper is all about implementation of AHP, analytic hierarchy process only, along the highways. Yeah. So these are the contents. We will begin with the introduction and objectives of the study. After that, go to the study area, literature review, what kind of methodology we have adopted, the different causative factors, and after that, how we performed this study along the highways. So we know that crucial the hilly regions are developed at a very rapid rate in Indian continent. So there are numerous construction activities, the upgradation of highways, and many anthropogenic activities are taking place. That's why the slopes along the highways has become unstable due to these construction activities and anthropogenic activities that have been conducted. So there is a lot of human interference along the highways and even in all the hilly regions, because they have started developing from last 2-3 decades only. So that's why the infrastructure is growing. But as the infrastructure is growing, there is disturbance in the natural slope. That's why the number of landslide events have been significantly increased in the hilly regions in India. So the planning and management of landslides along highways is very important. Whenever a new highway is proposed or an existing highway is upgraded from for more lanes or for more width, at that situation, the landslide planning is very important for the hilly regions. So that's why landslide susceptibility maps and landslide hazard maps are one of the very efficient tools in predicting, planning and management of the landslide hazard. With a small definition of landslide susceptibility maps that is given by Geological Survey of India, Geological Survey of Ireland, that it identifies the areas which are subject to landslides and is measured from low to high. So the objective of our study there are only two objectives: that we wanted to identify the causative factors of the landslide. This can be done by the literature, the available literature, or by the field visits. And second, we attempted to prepare a landslide hazard map along the proportion of National Highway 5 in India, in Shimla. So let's talk about the study area. Our study area was National Highway 5 and the stretch of a national highway. And it is situated in Himachal Pradesh, in Shimla and Solan districts. While National Highway is a long highway, it is around 600 kilometer long, but all the complete stretch don't go through the hilly region. That's why we have selected only the part that goes through the hilly region, and that is from 197 kilometer to 283 kilometer along the National Highway 5. The longitude and latitude of the study area are given here, and it lies in that. And the elevation of the study area, there is a very high variation in the elevation. The elevation from the mean sea level varies from 591 meter to 2459 meter. And the temperature of the study area also varies significantly, like 6.2 degrees Celsius to 36.7 degrees Celsius. However, even this is the average temperature, the variation of average temperature. However, in the in winter season, it goes near about, the minimum temperature goes near about 0 degree and all. So it is a crucial region, as Shimla, our study area, is the capital of Himachal Pradesh, that is a province in India. So it is very important according to economic point of view and socially. So we have separated our study area, we have extracted our study area. Here the first map shows the map of India, and here lies the Himachal Pradesh province, where our study area is situated. In Himachal Pradesh, these are the various districts. Our road, that is along which we are conducting the study, lies here. That is part of Solan district and Shimla district. And the elevation is shown with various color combinations. So before selecting the analytic hierarchy process for this study, we have gone through some literature, and and the techniques for landslide hazard assessment and landslide susceptibility mapping in GIS environment and are basically divided into three parts. The first type of methods that are used are qualitative techniques. Second one are quantitative techniques, and another one is semi-qualitative or semi-quantitative techniques. The qualitative techniques are based on the decision of the expert, where the expert suggests the contribution of various causative factors in occurrence of landslide according to their wisdom. So qualitative techniques are purely expert-based techniques. In this, the evaluator selects the relative importance of causative factor. So these are very simple to implement normally, as these are based on the judgment of the expert at that situation. We don't need landslide data. I mean, if the landslide data is not available for a particular area, then it is all right. We can go for the expert weightage, and they will not be requiring any landslide inventory. If it is available, it is good. It will help in taking the decisions by the expert, but otherwise, it is not mandatory for this. But the problem in the qualitative method is that the first, it completely depends on the subjective judgment of the expert. So the judgment of the experts can vary from expert to expert, depending on their experience. So that's why it don't give much accurate results. And even the accuracy of such techniques can't be evaluated if the landslide inventory is not available. So second one are the quantitative techniques. The quantitative techniques uses the mathematical relationship between occurrence of landslides and the causative factors. So various statistical and mathematical models that are available for landslide susceptibility mapping comes under category of quantitative techniques. So these methods depends on the spatial distribution of landslides. So the one thing that is important for implementation of quantitative techniques is that for accurate result, we will be requiring a very well distributed landslide inventory. Means I should have the historical landslide data. Only then we will be able to implement the quantitative or mathematical models, as these develop the relationship between occurrence of landslides and the various causative factors of landslide. So these two techniques are widely used by various researchers, and this one more, there is other technique too, that is semi-quantitative technique or semi-qualitative technique. It is a kind of hybrid technique where the expert opinion is used, but it is restricted by some mathematical model. Means some validation is taken by the mathematical equations and all. So with the help of some mathematical relationship and the opinion of expert, we can predict the occurrence of landslide, or we can predict the landslide susceptibility. Such techniques comes under category of semi-quantitative techniques. Now in our study area, whenever this work was conducted, so it was difficult to conduct the field work. At the time of COVID, we were not able to make frequent visit to the study area, and we were unable to take the data for landslide inventory. This was the case one. Second, we can use the Google Earth data for preparation of inventory, but still this data should be validated with the ground stations, and we were unable to do that due to the restriction in movement. That's why we selected a semi-quantitative technique, and in semi-quantitative technique we selected the analytic hierarchy process for this study. So, and in analytic hierarchy process, in simple words, we break the problems into the criteria, and these criteria are given weightages according to their relative importance, and then the ranking of the criteria is evaluated. Once the ranking of the criteria is evaluated, we can overlay them with that weightage, and we can get the landslide susceptibility or landslide hazard map. So this is a scale that was given by Sati, Thomas L. Sati, in 1980, and it shows that how we compare the criteria. If in a pairwise comparison matrix I give value 1 to 2 criteria, then it means that both the criteria are equally important. If one criteria get value 3, it means that one factor is more effective as compared to the other factor, and so on. And similarly, the intermediate values are also possible. So this is our table. This table shows the pairwise comparison of various factors that are considered in this study. In this study, we have considered around 9 factors, and the first causative factor that is considered in this study is slope gradient. Slope gradient is divided into 5 categories as shown in the table, and the pairwise comparison is shown for slope, the various subcategories of the slope gradient. And according to AHP, it is found that the slope gradient that was 45 to 60 degree has a weightage of 0.262. Its contribution is high, and as the slope gradient is increasing, its contribution towards occurrence of landslide is increasing in this particular area. So this is based on the expert weightage, or the perception of weightage, perception of experts. Similarly, the second causative factor is the aspect, and we have compared the various aspects, and we have prepared the weightage according to AHP. There is a term consistency ratio. The consistency ratio is the restriction that makes this method the semi-qualitative or semi-quantitative method. The consistency ratio restricts the values. Like if the consistency ratio is more than 10%, then in analytic hierarchy process, it is considered that the weightage given by the expert are inconsistent, and the input can be varied. Means the input can be varied and the values can be changed to get the better consistency ratio. So in this process, we have maintained the consistency ratio below 10%. So similarly, we have other factor like curvature. It is seen that the concave type of curvature were more susceptible to the landslides. The relative relief varies from 0 to 254 meter, and again the weightages are given. The geology of the area has a wide variety of geology, and there are various groups of soils that are encountered in the study area and are weighted. Similarly, the lithology is considered the another causative factors of landslide. And fault density is the another one. So we have considered 9 factors for preparation of landslide susceptibility map. We have prepared the pairwise comparison matrix. We have compared them and got the numerical index with the help of analytic hierarchy process. This was our methodology, that the slope, aspect, curvature, relative relief, and topographic wetness index is extracted from Aster DEM. From DEM, we have extracted this data. The landslide inventory, however, validated from the field data. We visited the field and performed our studies, but Lot of data is taken from Google Earth too. And with this combination, we have prepared the landslide inventory. Here in India, there is an agency, that Survey of India. We obtained these maps from Survey of India, and after that we have digitized these maps in GIS environment. Now, taking this all data, we have assigned the weightage according to analytic hierarchy process, keeping the consistency ratio less than 10%. And with help of AHP, we assigned the weightage to the causative factors and prepared the landslide hazard map. And then landslide hazard map is validated using area under curve and receiver operation characteristics curve characteristics. So these are the inputs that have been calculated in the study. The first one is the slope map along the national highway. We have taken a buffer of kilometer, 1 kilometer each side of the highway, and up to that we have prepared the hazard map. So these are the various inputs that are calculated. So here is the geology map, relative relief map, lithology map, fault density, drainage density, topographic wetness index, and distance from road. Distance from road is the most important parameter as we are studying the landslide susceptibility along the highways. It is seen that whenever the highways are constructed in this study area, when this particular highway, National Highway 5, was constructed, the bottom portion of the slopes was gone through a huge cutting activity. So it was cut. That's why the toe of the slide has become unstable, and the overturning problem is there. So that's why we consider this factor. And as we reach near the road, the slopes are more prone towards landslide in this particular study area. So using AHP and after implementation, we also compared the various major causative factor too, and we received this kind of weightage for the study area, that the contribution of slope was this, for aspect was this, and so on. So each numerical weightage shows the contribution of each causative factor, and the contribution of sub-factors is shown in the table above. So the landslide hazard index for our study area is based on this equation, and the landslide hazard index varies from 0.0783 and to 0.576. It is found that 40% of the study area lies under very high susceptibility, while 23% of the region lies under high susceptibility. So this is our final map that shows the landslide hazard or the landslide susceptibility of the region. The landslide data is shown with dots. The red color shows the landslide testing data, and blue color shows the landslide training data. It has been zoomed, otherwise it will not be visible on such kind of map. So this is the final output, and based on this, we gave the results that how much area is susceptible towards landslide and how much is not. So we tested the work, we tested the accuracy of this output on the receiver operation characteristic curve, and it was observed that the accuracy was quite good. But the accuracy completely depends on the available landslide data. So moderately, it was quite accurate. So these are the conclusions. We have used 10 causative factors, and we had a data of 215 landslides, and 70% of the landslide data was used for training and 30% was used for testing purpose. And the landslide hazard map was divided into 4 zones, and the output is calculated. So in case of analytic hierarchy process, there is the only problem is that again it consider the opinion of expert, and we check its consistency, but there is an opinion of expert which may be subjective. Secondly, if a good landslide inventory is available, then more accurate results can be predicted. The statistical models we have observed from the literature are very accurate if the historical data is available, and the expert-based models are have somewhat not that good kind of performance in case of that are purely based on the expert opinion. So this work is published in Ancient Engineering Journal this year only. It was published in like 2022 in the edition of May. And our few other works are also published that evaluates the statistical model in landslide susceptibility mapping too. So that's it from my side.